I say welcome to Kaushal, and Kaushal is one of my colleagues. How are you doing, man?
Doing good.
Excellent. Some delay on the line, I don't think so, but maybe it's also my system. So yeah, Kaushal, I asked you to share some of the examples, case studies. I mean, from a couple
Right.
of different type of organizations, and actually looking at, how does it look like? What is it, and how does it present itself on the shop floor or in different situations. And I think you will be given access by Kitan, and we'll be juggling a little bit around left and right. Also, apologies
Okay.
for the weird start, but Kaushal is in control, and please.
Okay, great. Yeah, thank you, Dimitri, for the introduction, and I hope everyone's enjoying this webinar and getting some good insight into the future of immersive learning. So as Dimitri said, he's asked me to prepare a few demos and rather show you the demos that we have built over time for our customers. And I've developed a few sessions here, and I want to show you what each of these demos will have to how they benefit our customers, right? So let me introduce you to what you'll be seeing today. In the first demo, you'll see the user is taking advantage of kinesthetic learning. Okay, this is where you're learning via doing physical activity rather than just observing. This is proven to increase knowledge assimilation and retention. Okay, in this demo, you'll see the users grabbing tools and walking around the machine as they would in real life. The second demo you'll see is of a virtual environment in which the user must perform a series of steps to put out a fire. So this demo provides a lifelike environment in which they can train in without putting themselves in danger. The third demo is of an area in which the user is training collaboratively to assemble automotive parts, enabling them to be trained from a convenient location without having to travel elsewhere. So what you will see from these training scenarios that immersive visualization can enable effective training of different users, operators. You'll have emergency response teams, and they go through these training through full immersion, realistic environments, active learning as well. So as more and more companies are embracing the buzzwords, the digital transformation, right? They're leveraging immersive learning as a tool to train their employees. And our research shows that immersive learning programs are 30 to 70% more effective than training, classrooms or e-learning. So it's an absolute game changer for teaching someone something that is complex, something that's mission critical. So without taking up any more time, let me jump into these demos here. This virtual training scene is created for a food and beverage company specializing in meat rendering equipment. The CAD model was provided by the customer and imported into Visionary Render using one of 30+ importers. The textures and colors were added along with the animation sequences to create this training scenario. The purpose of this training is to help train technicians and engineers on how to overhaul the presser unit as seen here. It will allow for faster and safer training and will save resources. This training scenario takes a stepped approach to how the user must perform procedures in real life. The guided instructions are placed in the scenario to allow for new employees to rehearse the procedures before they service the real machine. Going through the procedures virtually, engineers can identify any problems in servicing and optimize their maintenance process. The stage sequence prevent removal of part B before part A and require correct tooling to perform a task. Being fully immersed in a head-mounted display, the user must perform physical movement as they would on the plant floor. This virtual training allows for users to run through the procedures 10 times in the time taken to do it once physically, and improve training retention. Doing virtual training allows users to train from remote locations and practice using virtual components, reducing the risk of costly maintenance errors and added downtime. So by adopting virtual reality training, this customer is already seeing ROI up to 78% improved retention, 40% reduction in training cost, and 30% reduction in training time. This scene was created for a leading oil and gas offshore company specializing in oil exploration and drilling. The purpose of this virtual scenario is to train oil rig workers to respond to fire emergencies and decrease unplanned production downtime, for which the customer was losing an average of $500,000 a day. The customer wanted to increase safety, decrease production downtime, and continuously train current and new employees to be better prepared. So in this scenario, the user can navigate to all the important parts of the drilling rig to familiarize themselves using viewpoints on the left. The user is seeing glimpses of what they would typically see on the oil rig. The training scene starts by having a small fire start near a key equipment, and due to a leak causing an explosion, and as a result a larger fire. This starts the alarms and flashing lights all over the rig. The next step is for the oil rig worker to go to the computers in the control room and identify where the damage is and reroute the flow of hydrocarbons to stop the leak. For this, they must press a few buttons and pull a lever to reroute the flow of hydrocarbons. Once the flow is rerouted, the oil rig worker must put out the fire by grabbing the fire hose reel and walking a safe distance away from the fire. They must spray the fire with foam, and after some time, the fire will dissipate. Once the fire is put out, the worker then goes back to the control room to reroute the flow to the correct process. This will happen once the emergency button is reset and the lever is pushed back. By having their employees go through this process virtually, they can experience real-life scenarios without being put in hazardous situations. The customer was able to reduce the number of fire-related incidences down to almost zero. They also increased their productivity and profitability as the workers knew how to handle similar situations in a timely manner. This resulted in decreased production downtime and savings of millions of dollars per year. With virtual training, they were able to minimize operational risk and eliminate reputation-damaging safety incidents. This training scenario is created for one of the largest manufacturers of chrome-plated plastic parts for the automotive industry. This customer's training methodologies were inefficient, time-consuming, error-prone, and required utilization of a physical work environment for the new training staff. By utilizing a physical work cell for the new trainees, they were reducing their production yield so the trainees could have a first-hand experience with tools and machines on the work floor. Not only it affected their production output, but it also required 4 weeks' time from an experienced trainer. The cost of trainer, the reduced production output, and inability to train more than one trainee at a time had a significant cost when viewed from an enterprise level. The customer adopted VR Training Lab as seen here to train their employees. Utilization of existing CAD models made creation of the training simulation much easier. The VR training scenario incorporates training instructor, trainee, procedures for each step of the manufacturing process. This allowed the trainee to demonstrate proficiency with familiarity, reducing risk and rework. The collaborative feature improved communication, reducing stress and improving employee satisfaction. As a result, the customer was able to implement a successful VR lab, ensuring that they were able to retain talent through innovation. It transformed how their team was able to work collaboratively, locally and globally, inside of a virtual environment. By adopting Virtalis VR technology, the customer was able to drive efficiency across their training operations and reduce training time by 50% and improve knowledge retention by 10%. So for the next set of demo, I would like to introduce my colleague, Paul McCall, who has prepared a narrative on the project we did for the National Grid in the UK. The National Grid trains their service and maintenance engineers using our immersive visualization technology, including simulation of typically hazardous environment in which they do their work. So let's see what Paul has to say.
Hello, my name is Paul McCall. I'm Systems Architect and one of the Solution Engineers here at Virtalis. What I'd like to show you today is a past project that we delivered for the National Grid in the UK. For those of you that don't know the National Grid, they own and manage the UK's national transmission networks for both gas and electricity. So here at their training centre in the centre of the UK, they've built what we call an above ground installation, or AGI. The AGI is a substation, it's a distribution substation for gas, and it uses real hardware and is exactly representative of what they would find in the field. They built it at the rear of their site in a clear zone. And although not filled with potentially explosive gas, this is highly pressurized with air to simulate the correct experience that an engineer would have on a pressurized gas system. Releasing compressed air wrongly can have explosive effects and can cause serious injury. So to prepare students prior to exposure to this potentially hazardous training scenario, they're walked through and can practice maintenance on a digital twin of the physical system. This digital twin we can see here. So on a digital twin, we've got a number of different areas that we can look at. There's the filter skid, the regulator cabin, the meter skid, or the pigging loop. So if we fly down, for example, to the meter skid, we can see here that we've actually made it transparent so you can see through it. That's switchable, so we can start with a plain system. The students can then turn that transparent, and by turning it transparent, we can actually begin to see how gas will flow through the network. So here we have gas flowing past an impeller. Here we have the gas going through a reducer ring. We can also see how impurities in the gas are measured using both ultrasonics and lasers. But one of the great examples of how this training scenario might work would be over here in the pigging loop. So let's just set the pigging training scenario up. Here we can see a pig. The pig is the red item that you're seeing in the middle of the screen here. This is what an engineer would put into a pressurized gas system in order to do maintenance and cleaning of the inside of the pipework. Normally they'd be expected to do all of this work out in the field without any cues, perhaps just their instruction manuals. However, here, for the first time students, we can throw instructions up on the screen and guidances. Now let's remember that this is often done in front of a large scale screen, so something that's 8 or 10 feet across. The student can stand in front of this screen and use his hands to actually manipulate the virtual reality scenario while a trainer is watching on and while the rest of the students are learning from his actions. So let's run through a couple of these steps. Here we can see it's asking me in the bottom right hand corner to open balance valve 1. So we can walk down the system, easily spot balance valve 1. So that's here. And this valve handle that you can see needs to be opened. So we would select that and open it. We're then been asked to add the vent valve and open the pig trap valve. I happen to know that those are at this end of the system. So we need to get the vent valve out of the toolbox, add that, and then open the pig trap valve. We'll move to the vent valve down here, open that, and the balance valve. Now, although you may not be able to hear it on the audio that we're doing here today, there are audible cues going on in the background. You can hear gas being let out. You can hear gas flowing, so you get audible cues of how the system's operating. We then need to purge the nitrogen. Let's click the button and open the pig trap door, because that's now been depressurized, and load the pig. And these are some of the steps that a student might normally go through. I hope really that gives you an idea of what they might be doing and how they might be doing it. Once they've done it this way, they'd have to run through it with the cues switched off, of course. But that gives them an idea of how to load and train safely before they go into this real life hazardous area and try it on the physical equipment. That really concludes this little training example, and I'll hand back to the team. Thank you.
Kaushal, thanks for getting these examples. I think they speak for themselves and extremely powerful. So if you can show your camera, then please join me. Looking at the time, there you are, man. Thanks for putting them together. I think they're very relevant. There are a few questions. I mean, one of them, let's go very quickly. I mean, how much time would it take? I mean, that's a very difficult one. But tell us a little bit about the process, you know, for developing a training scenarios like the ones we saw. I mean, and keep it short, please. But
Sure.
please.
Yeah. So generally we'll work with the customer in developing their training steps on how they usually would perform a task. And then we'll request them to give us their CAD models for the users, right? What they'll be training on. And then from that point onwards, our customer success team will take that information and we'll build the training scenarios, right? We'll bring in the CAD models using one of our 30 plus importers mentioned in the demo earlier. And then from that point onwards, we'll add textures, colors and materials and things like that. Some of the behaviors that you saw, we will add that using some basic scripting. That's very easy to do. And our customer success team will then hand it back to our customers, and we'll train them on how to use the scene as well. And then we'll remain on the back end just to provide support. So in a nutshell,
they can do it themselves as well, you know. I mean,
correct. Yeah. We can either develop the scenes for you and train you how to use it, or we can train your team, and then we'll support you as needed.
Excellent.